Welcome back. This week we are going back to weather school with an easy experiment that will help us visualize what is happening when a cold front or a warm front slides through. First, I want to ask Sierra a very important question. Okay. What is more dense, cold air or warm air?
It's cold air.
Correct. That's the correct answer. A lot of people get that wrong. Cold air is actually more dense, thus it sinks to the ground, while warm air has the tendency to rise. So let's pull up our weather graphics here, and let me show you exactly what we're going to do here in just a minute. Take a weather system. Don't get too confused by the symbols that you see on the map. What you need to know is that to the left of that blue line, that's the cold front, is typically colder, drier air. To the east of that line is warmer, more humid air. Well, as Sierra had said, the cold air is more dense. It has a tendency to sink. There's a sinking motion with that air. The warm air is less dense. It has a tendency to rise. It just needs a little bit of a push sometimes, and that's what a cold front will do. The cold air sinks to the ground, advances towards the east, towards that warmer air mass. As it does so, it pushes that warm air upward, and that's how we get one of the basic ingredients for thunderstorms that's called lift. So let's see this put into action here with a simple experiment that's going to show you how warm air, or warm water in this case, will have the tendency to rise because it's less dense. What we need are two clear glasses. One glass is going to have very warm water in it. In fact, this water was boiling just a little bit ago, but we've let it cool off just a little bit. We're going to put some red food coloring in here. Now, the other glass has cold water in it. You have the option at this point. You can add blue color dye if you want to symbolize that that's the colder air behind the cold front. For me, and for the sake of this experiment, I actually think I'm going to do it today without adding the blue color dye. I think you'll be able to see the red do something once we do this a little bit easier just in terms of our cameras. So first things first, I'm going to take this glass of cold water. You can see some of the ice in here. I'm going to remove the ice cubes, which is always a challenge because it's slippery. But you don't want to have any ice cubes in here while you're doing this. There we go. We'll put the glass of warm water, and it is pretty warm, so please use caution. Parents, if you're going to do this, make sure you're the one that's doing this with perhaps an oven mitt when the water is really hot in the glass. Don't let your kids try this one because, again, it's going to be very hot. Notice I also have this bowl here because what we're going to do in a minute may be a little funny for the viewers at home if this doesn't work exactly how I'm planning. So, remember, we have cold air in this glass, we have warm water in this glass. This is cold water in this glass. In between, I have a CD. You can use an old DVD, an old CD. This one's a blank CD. Use one that you don't need anymore because you're going to get it pretty wet here. You put the CD on top of the cold water on the cold glass, like that. That's all you do. There's a seal that's going to form there. It's not going to hold, but it will be enough to make this experiment possible. A simple flip of the cold water on top of the warm water, and be very careful here. You're going to lose a little bit of water. But once you get them on top of each other, you can watch as the red water rapidly lifts into the cold water. Why is that happening? Because the warm air is less dense. It has a tendency to rise, so the water that has the red food coloring will continue to rise up, while the clear water, or as I said, you could make it food coloring blue water, will have a tendency to sink. You can watch that happening. I challenge you at home to try an experiment similar to this and also try it in reverse. Try to put the warm water on top with the cold water below and see what happens. It's going to be pretty cool because if in that case you put the food coloring in, the red and the blue, they won't mix at all. So that's a pretty cool experiment for you. Maybe you learned a little something there about how weather fronts work.